have a network where we have two batteries, 30 volt and 15 volt battery with the polarities as shown, and we have three resistors, 10 ohm, 10 ohm and 10 ohm, and rest of them they are connected through conducting wires which have a resistance equal to 0. We are asked what is the current reading in this, that is what is the current which is flowing in this wire, and we also have to find out what is the direction of the current. So over here, if we see, we cannot use directly Ohm's law and get the answer. KCL and KVL, that is Kirchhoff current law and Kirchhoff voltage law, they become quite handy to solve questions like this. So the first step is, let's give the name to the various loops. I say A, B, C, D, E, F. This and this, they are junctions. Junctions are the points where more than two wires they meet. So over here we have one junction, this is also junction. Obviously in this wire, if we talk about this wire, there is no junction. So whatsoever current is flowing in this direction, the same current should be flowing in this direction. Generally the students, they have a confusion, that is if the current I is coming from here, then over here the current may be something different. No, in this one arm, whether there is some battery or not, in one single arm, whether there is some battery or not, the value of current and direction of current will remain same. It cannot change. We cannot say current I1 is coming from here to here and current I2 is going in this direction. We cannot say. If the current I1 is flowing, it will be I1 in this direction, and over here also I1 in this direction. If I2 is in this direction, I2 will be in this direction. So direction of current in one arm is going to remain same. Now we have two junctions over here and over here. So first is, whenever you have questions like this, so our first law is Kirchhoff current law. Let's apply first Kirchhoff current law. So over here we have two junctions. Let's see, we use I over here, that is we say current I1 is coming in this direction. We can take I2 here also, any direction we can use, any direction we can take. So over here I say that this is I2 is over here. So it means when the I1 is coming over here, I2 is here. Let's say 10 ampere is coming over here, 3 ampere goes over here, so remaining should be in this direction. So it is going to be I1 minus I2. I put it in circle. So when we are so engrossed, at times we make a mistake of taking currents as resistances, resistances as currents. So these encircled, they remind us that is these are the currents. So I1 minus I2 comes over here, I2 is here, so over here this is I2 only. In this whole arm the current will be I2 only. If I1 we have taken over here, so the I1 only shall be flowing in from E, F, A, B. When we look over here also, I1 minus I2 is coming from here, I1 minus I2 is coming from here, I2 is coming from here. So this makes what? I1 only, that is I1 only. You could have also taken I1 in this direction, I2 in this direction, and I1 plus I2, then it would have been moving in this direction, that doesn't matter. Finally, what is the value of current? That will come out to be same. What are the directions you take when you apply KCL and KVL? The value of I in this wire, in this wire, in this wire, it will come out to be same irrespective of the direction of current you have taken. Now let's apply KVL and we go for the loop A, B, E, F, A. We take the loop A, B, E, F, A. We are starting the loop with A, we are ending the loop with A only. From here, when we go, this is V is equal to IR, only Ohm's law we are using, that is potential difference we are using, potential difference plus difference plus difference plus difference, and finally that potential difference between the point at the same point is going to be equal to 0 only. So from here it is, conventional current is going in this direction because there is loss of potential, so minus 10 into I1, that is V is equal to IR. There is a loss, that's why it is negative. When we go from here to here, once again the current is going in this direction and in this direction. So when we say A, B, E, F, A, so we shall be moving in this direction only. We are moving in this direction. In the direction of current, there is a loss of potential. Against the direction of current, there is a gain of potential. So when we are moving from A to B to E to F to A, when we are going from A to B, we say the current is going in this direction. We are going in this direction, current is going in this direction, so there is a loss. Loss is minus 10I. For this, once again, there is loss. So it is minus 10 into I1 minus I2. We come over here. Now we are moving from negative to positive terminal. So there is a gain of potential, that is plus 30 is equal to 0. So from here we get, that is minus 10I1 plus 10I2 is equal to minus 30. Or we can say 20I1 minus 10I2 is equal to 30. It's one and the same thing. So we have multiplied both the terms by minus 1. So this is one equation we get. Now let's take other loop. Let's take a loop B, C, D, E, B. B, C, D, E, B. We are starting with B, we are ending with B. You could have taken this loop also, any loop you can take. Let's say we have taken B, C, D, E, B. We are going from here to here to here to here to here. In the direction of current, there is a loss of potential, so it is going to be minus 10I2. So when we go from here to here, positive negative, there is once again the drop of potential, minus 15. Once again, now the current is going in this direction and we are moving in this direction. So against the current we are moving. Obviously, when the conventional current we have seen that is moving in this direction, we know conventional current moves from a higher electric potential to lower electric potential. So electric potential of this is greater than this. So when we are going from here to here, there is a gain of potential. So it is going to plus 10 into I1 minus I2. That should be equal to 0 because now we have once again reached B. So this gives minus 10I2 minus 15 plus 10I1 minus 10I2 is equal to 0. So this makes 10I1, let's take first I1 terms, 10I1 minus 20I2 is equal to 15, it goes over here. So this is the other equation we get. Now if we multiply both the sides with 2, so that eventually we can compare these two, so this gives 20I1 minus 40I2 is equal to 30. Let's write it over here. So this is 20I1 minus 40I2 is equal to 30. If we subtract this from this, so it is minus plus minus, 20I1, 21 get cancelled, minus 10I2 plus 40I2 is equal to 30I2. 30 minus 30, that is equal to 0, so it means I2 is going to be equal to 0. If I2 is equal to 0, we can put I2 is equal to 0 in any of the equations. Let's say we put it in this equation. So this comes out to be 10I1, so this is 0, is equal to 15. So I1 comes out to be 15 by 10, that is 1.5 ampere. So I1 comes out to be 1.5 ampere. It means I1 is 1.5 ampere. Over here that current which goes is, it is 0. So the value of I1 minus I2, that is 1.5 minus 0 is 1.5 ampere. So current is 1.5 ampere in this direction, downward direction in arm BE. So the ammeter reading will be 1.5 ampere. Though we have got the answer, but let's write the equations for KCL and KVL to have a better understanding of both these laws. Over here this time what we can do is, we can take this current as I1, we can take this current as I2, and over here the current I1 and I2, they are approaching this junction. So this current is going to be equal to I1 plus I2, or you can take it as I3. So it means I1 plus I2 is equal to I3. So this is our one equation. You can take, so now over here we have three variables. If you wish to reduce the number of variables, you can write directly as I3 as I1 plus I2 only. Now let's write the equations for the various loops, that is we intend to apply Kirchhoff voltage law. Let's take this loop ABEFA. ABEFA. We shall be starting our journey from A and we shall be moving in this direction and we shall be reaching back home at A only. So when we apply KVL, so in the direction of conventional current there is a loss of potential. So it is minus 10I2. In the direction of current there is loss once again, so minus 10 I3. This is voltage potential difference. I3 into 10, that is potential difference. Because there is loss, so that's why there is a negative. We reach over here. From here to here when we go, it is plus 30 is equal to 0. One equation. We are just bothered right now about writing the equations. We are not much bothered about getting the answer, but let's get some proficiency in writing these equations. We take this loop, let's say B, C, D, E, B. We are going in this direction. So when we go from here to here, we see the current is in this direction. It is going from higher electric potential to lower electric potential. So it means when we go from here, we are going from a lower electric potential to higher electric potential. It means we are gaining potential. So it is 10I1. We have reached here. Now from positive to negative, we are going down the potential. Minus 15. We reach here. Now the conventional current is coming in this direction and we are moving in this direction. So once again there is a gain. So plus 10 into I3, that is equal to 0. That is second equation we get. So we have three variables, I1, I2 and I3. We have three variables and we have three equations. One is this, second is this, the third is this. But if you are just interested in writing the equations, let's take a bigger loop. We can take this bigger loop also. A, B, C, D, E, F, A. If we take this bigger loop, once we have assumed that currents they are moving in this direction, so this is the direction of conventional current we have assumed, we need not bother whether the currents they are flowing in this direction or not. Eventually KCL and KVL will give us the value of the current and direction of the current also. So when we take this loop, so it is going to be in the direction of current, it is going to be minus 10 I2. From here to here, conventional current is going in this direction. So we have a gain of potential, that is plus 10 I1 minus 15. Now we don't have to bother about this wire. When we are talking the loop, we have to talk only about this loop. Whatsoever current is flowing in this wire or not, this will be taken care of when finally we solve these equations. So we have reached over here, negative to positive, that is plus 30 is equal to 0. So now we have written all the equation for all the loops, for this loop also, for this loop also, for this bigger loop also, and we can solve, and once again we can get the answer.